Hello everyone! Today we're going to prove the sine and cosine formulas for double angles. As you can see, we have a circle here. Now let's call the angle at point B alpha. Since this is an exterior angle, the arc it intercepts is twice that, so that makes it 2 alpha, right? To keep things simple, let's assume this is a unit circle, meaning its radius is 1 unit. That means the angle at point A also becomes alpha. So the central angle at point O becomes 2 alpha. Now let's draw a perpendicular line from point A. Can you tell me what's the length of this line we just drew? To find the opposite side, we multiply the hypotenuse by the sine of the angle. So the length of this line is sine of 2 alpha, right? Similarly, the adjacent side, DO, is cosine of 2 alpha. Now let's draw a perpendicular from point O to line AB. What's the length of this line? It's sine alpha, of course, and EB would be cosine alpha then. Similarly, AE is also cosine alpha. All right, now look at this big green triangle. We'll do similar things with this triangle, using the alpha angle at point B. To find the length of side AD, I need to multiply the hypotenuse by sine alpha. This gives us sine of 2 alpha equals 2 times cosine alpha times sine alpha. Yes, that's our first important theorem, and we've proved it. For side DB, we multiply AB by cosine alpha. This gives us cosine of 2 alpha plus 1 equals 2 times cosine squared alpha. If you move the plus 1 to the other side as a minus, you get cosine of 2 alpha equals 2 times cosine squared alpha minus 1. Sometimes, you'll see this theorem written as cosine squared alpha minus sine squared alpha. I'll let you figure out how we got to this form. Write your answers in the comments. So we've covered the expansion of double angle identities of sine and cosine. As I mentioned, we'll keep working on proofs for a bit. Then we can move on to solving problems. See you soon.